The Atlantic Wire Company was founded at the corner of Meadow, Church and Meadow Street in 1906 by William E. Hitchcock, Sr. It was Branford's third largest factory and employer. What was Branford like in 1906? The population was about 5,800 people scattered around town, but many living in Branford Center. Many of the side streets in the center had been developed, and the men could walk to their place of employment. Families from Ireland had been here for over 40 years. Scandinavians were already here, and the Italians, East Europeans, and African Americans from the South were soon to join them. Branford was growing rapidly, with many changes occurring in transportation. The trolley had just arrived and the first automobiles. Like today, the green was the center of town activity. Men started working at the factories instead of on the farms. The Branford Lock Works was established just after the Civil War and made locks, knobs, and all manner of window and door hardware. Many Irish families came to Branford to work at the Lock Works. The factory was bought by Yale and Town, closed in 1902, and moved to Stamford. Atlantic Wire's neighbor was the Malleable Iron Fittings Company, known as MIF, and was founded in 1854 and was Branford's largest employer. The company produced hundreds of iron, steel, and special metal products, employing at its peak 1,200 people. The factory closed in 1970. Meadow Street was a busy place in the early 20th century. The passenger station was across from MIF, and the train was the preferred mode of transportation. Osborne's Feed and Grain was another neighbor on Meadow Street for many years. Many of you will remember when the old grain elevator was destroyed by fire in 1962 and scorched that side of Atlantic Wire. This view up the Branford River shows the Indian Neck Avenue Bridge, MIF, and other businesses along the river. In the upper left corner are the train signal tower and the freight depot. It is here, formerly a potato field, that Atlantic Wire was built. William Hitchcock Sr. was born in New Haven and worked at a number of New Haven factories, including New Haven Wire Manufacturing Company, later National Wire, and others. Starting out as an office boy, and though not formally educated, he was obviously smart and rose through the ranks to manager. The newspaper noted that Mr. Hitchcock was a thorough and up-to-date practical businessman with fine training. He had a reason for coming to Branford. He had met and married Sarah Wilford of Branford in 1902. They had 5 children: Harriet, who married Harold Welch, a banker from New Haven; William Jr., Mary, who married F. Sherwood Boyd, treasurer and vice president of Atlantic Wire; Louise, and Betty. They lived in the Wilford homestead at 107 South Main Street for the rest of their lives. This house still stands today, though it has been enlarged. In 1918, the family purchased a former inn in Pawson Park and enjoyed the summer cottage for many years. William Hitchcock was familiar with the property, some of it originally belonging to Sarah's ancestor, John Wilford. He chose it for its location along the railroad and access to metropolitan areas. He named it Atlantic because it began with A, and so would be listed first alphabetically in business directories. In this photo from the 1905 bird's eye view map, you can see an extension of Church Street going to the freight depot and Osborne's to the left. The first building was wood, a barn-type building with truss construction. We know of no exterior photos of this 1906 building. He purchased a wire company in Pennsylvania with the help of investors and brought the equipment to Branford. He soon paid the investors back, and the family owned the company for 78 years. He also brought about 25 men he knew from the wire companies in New Haven, including the superintendent of New Haven Wire. The company had their own power plant, first with gas and later steam, upgrading many times through the years. William Hitchcock believed in fair business practices and that quality was more important than quantity. His motto was, "There was always a market for the best." This photograph from around 1910 is 60 years before OSHA, the Occupational Safety and Health Administration, was formed. He was a hands-on owner, visiting the men daily on the floor, and he knew all about their families and loaned them money during hard times. The plant soon expanded with its first brick building in 1911 and a large addition in 1915, so familiar to us along Meadow Street. There were many new buildings and additions through the years, especially in the 1930s and 1950s. Not as visual to the public is the railroad side, with many buildings, most of which were interconnected to the main plant. Eventually, the wire mill, as it was called, had 172,000 square feet of floor space on nearly 9 acres. What did the company make? Well, of course, they made wire. Atlantic Wire made a wide range of wire for many different customers that, in turn, used the wire to make hundreds of different diverse products. The wire mill made low-carbon wire in many diameters, grades, with various coatings and shapes, coarse to fine, round, half-round, oval, and flat, plus a few specialty wires. How was this wire made? The process is complex, involving physical and chemical properties, and has many steps. Though technology changed and equipment became faster and more automated, the process of making a hunk of steel into fine wire is still the same. Atlantic Wire got most of their material from Bethlehem Steel in Pennsylvania, at that time the second largest mill in the country. A steel billet, which could be round or square and vary in length, was soaked, then heated to 1700 to 2200 degrees Fahrenheit and put through a rolling mill where it was elongated and made into a rod. The hot rolled wire rods or rod coils generally had a rough surface and variations in diameter throughout the coil. Atlantic Wire purchased tons and tons of rod coils later from other steel mills throughout the country and overseas. The coils weighed between 300 and 1,000 pounds and varied in diameter and grade. For many years, the coils came to Atlantic Wire from the steel mills by train to the freight depot previously mentioned. Later, it was brought in by truck. Originally, the railroad siding split off from the main track a little north of MIF and only went as far as Osborne's, seen here toward the back of the photograph. In 1951, William Hitchcock purchased land towards Montague Street from the New Haven Railroad and built a new rod shed extending the track to the new building. At that time, the brick wall at Montague and Meadow Streets was built. 4 cars could be brought directly into the new rod shed and offloaded. There was an extensive overhead crane system to move the rods around. There were 2 rod sheds to store higher carbon content coils, which rusted faster, and much of the property was used as the rod yard. The wire mill handled about 10 different sizes and 30 different grades of steel rod. Some of my favorite photos of the mill are the rod yard. I always thought this was wire ready to be shipped out to customers. It is not wire, but rod coils from the steel plants. Note the tracks going into the 1952 rod shed. This photograph shows the overhead bridge crane and the coils in the shed and the yard. There was an extensive office staff, administration, personnel, metallurgists, engineers, salesmen, bookkeepers, and others. Before the rod coil began its trip through the mill, the production planner determined how that coil would be processed through the plant. The steps undertaken and where it went in the plant were determined by the kind of wire the customer needed for their products. Each coil had a tag from the steel mill with its physical properties such as carbon content and diameter. In addition, the schedule card went with each coil, and the foreman of each department made sure the schedule was being followed. The rods rusted easily, called mill scale. The rods came in from the yard to the cleaning house. The location of the cleaning house moved through the years, and there was a big and a small cleaning house. In order to get the mill scale off, the coils were lifted by an overhead hoist. Originally, these were manual and later electric. The coils were lifted into 6,000-gallon vats of diluted sulfuric acid heated to 1,200 degrees. This cleaning process is called pickling. This photograph shows the original cleaning room. Note the wood walls. The vats were made of Stony Creek granite and were used for many years. After about 15 minutes in the vat, they were lifted out to a spray rack. Once the mill scale was sprayed off, the coil is bare metal. The wire mill had a laboratory with a chemist and laboratory technicians who checked the chemical composition of the sulfuric acid and other chemicals used throughout the plant. The acid could be reused, but only as long as the composition was correct. Because the coils could easily get rusted again, they were placed in a tub of lime, still in the cleaning house. This photograph from 1936 shows how the coils came in from the rod yard and shed on carts along a track. The coils were lifted into a vat of lime, heated to 300 to 550 degrees for 10 minutes to several hours, depending on the grade of the wire needed by the end user. The lime vats are on the right. The lime coated the rod to prevent further mill scale. Another coating that was used was borax. The rods were removed from the vats and placed in a baker where hot air baked the lime on. This photograph is from the old cleaning house and shows bakers number 1 through 4. Some of the coils are blackish. These are the ones that had borax treatments versus lighter color or whitish that had lime coating. A number of coils were put on a cart and pushed into the front door of the furnace. This photograph is of a newer cleaning house, but still old, with the lime vats on the right and the new baking furnaces on the left. Note the more modern overhead hoists and the size of the coils compared to the previous photo. After being baked, the rod coils were put on the floor, and a ram truck operator brought them to their next scheduled destination. Remember, this isn't wire yet, it's still rod. Now we are ready to make wire. The wire is first drawn or pulled, not pushed, through a die or a series of dies. This is usually done at room temperature and is called cold drawing. The die is smaller than the diameter of the rod and physically forces the size of the rod to decrease and lengthen as it is drawn through the die. Some rods get drawn just once, others multiple times, depending on the size and shape of the wire needed. After World War II, new drawing machines could draw the wire continuously. The wire mill bought rough-cut dies made of tungsten carbide and tooled them to the desired diameter in the die room. The company had many fine machinists through the years working throughout the plant, allowing the company to build and repair much of their own equipment. The dies were reused by making them smaller until they were beyond their useful life. Diamond dies were used for very fine wire. You will note in this picture of the die room, there's a picture of Princess Diana on the wall. Because the rod was bigger than the die, a point was put on the end of the rod, the green machine in the center. In this photograph from the 1980s, you can see that these rod coils have been limed and how much larger the coils were than in earlier photographs. Note also the tag on the coil on the left. The pointed end of the coil is placed in the drawing machine and loops around and is drawn along with a capstan, C-A-P-S-T-A-N. The capstan not only draws the wire through, but regulates the speed and tension of the operation. Between each capstan is the die in a block. The die reduces the diameter of the rod, shapes, and elongates it. There is tremendous friction caused by physically altering the rod and making it smaller. These are the rams brought by the truck from the cleaning house. After getting a point, the end goes into the drawing machine. Here you can see the wire entering the machines. To lessen the friction, the die box has soap as a lubricant and sometimes soap and water. This determines whether it is a dry drawing or a wet drawing. Each successive die gets smaller and the process speeds up due to the decreasing size of the wire. Yes, we now have wire. The wire is called cold finish and has a bright or finished metal look. This photograph shows a dry wire drawing operation. You can see that the wire enters from the left off this photograph, goes through a pulley, through a die block, and then around the capstan, and then around back again to a pulley and another die box. This is a wet drawing machine from the 1930s. Atlantic Wire employed many wire drawers. The wire drawing was done on the first floor in the Meadow Street brick building. This is another wet drawing machine from the 1930s. The pointed rod comes in from the left. The front shows a series of small dies in a die block, and the soap and water are behind it. The four round pieces are the capstans drawing the wire through. The wire comes out through the right. These dies were used for very fine wire. When the company started, wire was drawn at 75 to 300 feet per minute. By 1953, 2,200 feet per minute. This is a modern wire drawing machine. Their output can now reach 4,500 feet per minute. The process, though, is still the same. Note the dies and the capstans on this machine. Let's leave wire processing for a moment. William Hitchcock Sr. remained president of the company for the rest of his life. During World War I and World War II and subsequent wars, the company always held the jobs for those serving. When World War II began, the wire mill went into full war production. Starting in 1939, the mill made large quantities of barrage balloon cables for Great Britain. When the U.S. entered the war, the company went into 100% war production, 24 hours a day, 7 days a week. Because they had talented machinists, much of the equipment was converted for the war effort. Wire that had been used in the clock industry was used for wire and hand grenades. Wire from the plant was used for torpedoes, special bolts and screws for airplanes, wire for tents, guns, and for ship construction. The U.S. Signal Corps needed large quantities of disposable infantry field wire, and not enough could be made. Atlantic Wire was a pioneer in drawing galvanized wire at this small diameter and began supplying the Signal Corps. Women were hired for the first time for factory work and were given lighter tasks since 40 pounds was the legal maximum they could lift. They worked in testing, packaging, and inspection. They often teamed up with male workers for other jobs. William Hitchcock Jr. said the women worked all 3 shifts and their work was excellent. All the work at the plant was directed by the War Production Board in Washington, D.C. The number of employees increased from 150 to 265. It takes more workers to produce finer wire than coarse wire because the wire had more steps, drawing and cleaning. Atlantic Wire shipped out 2,200 tons of wire a month during the war. Once the war ended, the machinery was easily converted back for civilian work. One of the mill's first female employees was Marjorie Wilford, younger sister of Sarah Wilford Hitchcock. Marjorie was educated at Vassar and taught German and Latin in New Jersey. She joined Atlantic Wire in 1916, and shortly after World War I became a salesperson. Her brother-in-law told her to stay away from old-time customers who might, and I quote, flinch from dealing with the delicate sex. A newspaper article, however, stated that her delicacy wasn't hampered, and she traveled by rail and bus all over the East Coast, winning over many customers. She was promoted to treasurer of the company, was the first woman member and president of the American Iron and Steel Institute. She was highly regarded in the industry. A few women worked at the wire mill, not just in the office, but some did line work. For example, making wire for gold jewelry chains so popular in the 1970s. Let's get back to wire processing. Some wire went through only one die, other wire through multiple dies, depending on the diameter and grade needed by the customer. After drawing, some wire went directly up to the second floor to be tinned. An example would be for paper clips. This was called hard drawing. This wire didn't get annealed or softened between draws. Other wire got copper coated in a bath of copper sulfate. Another coating was called liquor in a molten bath of copper and zinc sulfite. The liquor-coated wire was used for the jewelry chains. Because there was such physical force converting a larger rod into a smaller wire, the wire gets brittle in the process. In between draws, the wire was annealed or softened to release the stress or brittleness of the drawn wire. This thermal treatment was done in two ways. The first, shown here, was a salt bath in potassium chloride, heated to 1200 degrees. The coils were immersed in the acid for about 1.5 hours. This treatment was called lava. The coils went back to the cleaning house, were pickled again, and then drawn again. An example was wire that was cold-headed, stamped to make ball bearings, screws, and bolts. The second softening process was called atmospheric annealing. This was called the Lee Wilson department, named for the man who invented the process. Several coils were dropped into the furnace on stems, seen on the right of this photograph. The furnaces were covered and sealed with oil so no oxygen could get in, hence atmospheric. The heat changed the molecular structure of the wire. This was a very busy department at the mill, and Lee Wilson eventually had its own building and replaced the lava treatment. During World War II, Lee Wilson had 9 annealing furnaces with a capacity of 6,000 to 15,000 pounds of wire. The stem was removed from the tank, the coils were removed and sent to the small cleaning house for pickling to prepare the coils for another wire draw. All along the way, the wire got strength tested, inspected, and weighed. Once the wire was finished being processed, it went to inspection and packaging. Some wire was shipped out to customers in small coils, some in larger coils, some cut different lengths and placed in barrels. The wire was then shipped out. These departments were in the back of the main building toward the railroad tracks. The start to finish operation took 2 to 7 days, depending on the wire. Atlantic Wire originally shipped some of their wire via horse and wagon and train. After serving in World War II, Emil Nygaard of Branford, called chief, started a livery business and was asked by William Hitchcock Sr. to start delivering for the company. Emil's father, Joseph Nygaard, was one of the first employees brought to Atlantic Wire from New Haven. Eventually, they had 15 trucks and hauled for Atlantic Wire, MIF, and Nutmeg Steel. Chief Nygaard built 2 buildings on Meadow Street. One was eventually associated with the wire business. Nygaard Trucking closed in 1979. Bill Hitchcock, grandson of the founder, worked at the wire mill for about 6 years and decided factory work and management were not for him. He started his own trucking business called Atlantic Trucking and hauled wire for Atlantic Wire and goods for other companies. He purchased one of Nygaard's Meadow Street buildings, by then used for wire mesh production, and continued in the trucking business until 2010. Remember, Atlantic Wire milled wire, which they sold to companies who made the end products. to name a few. In New Britain, American Hardware and American Screw. In Hartford, Abbott Ball, Atlantic Screw, Plimpton and Hills. In Waterbury, Scoville, Mattituck Manufacturing, and Waterbury Buckle. Farrell Machine Company was a longtime customer and had Branford connections. In New Haven, Andrew Hendricks Company made bird cages. In West Haven, there was American Buckle and a riveting company in Milford. Many of these companies are no longer in business. One of Atlantic Wire's main customers was Bostitch, the maker of staplers and other products. They had several plants throughout the country, one in Clinton. Already mentioned was paper clips. The mill made tons and tons of wire for that product. Some wire was used for cold heading, wire stamped into bolts, screws, screwdriver shanks, ball bearings, and belt buckles. Other products were wire for houses, electric lights, disposable scalpels, and tweezers used in hospitals. During the 1960s and 1970s, the company made flat or rolled wire for Tyco slot car tracks. This was done on the rolling machines on the second floor. Other products: bobby pins, metal hooks for girdles, horseshoe nails, towel racks, soap dishes, wire for lampshades, drapery hooks, clothing hangers, clothing pins, lawn furniture, mattress wire, notebook rings, umbrella frames, and wire for the textile industry. Scoville in Waterbury made safety pins and needles. The wire was used for fasteners and tacks of every kind. Some of my favorites are mousetrap wire and eyelash curlers. When Connecticut companies started closing, the mills sent their wire along the entire East Coast, Midwest, and overseas to Canada, Mexico, South America, Europe, India, Korea, and Hong Kong. William Hitchcock Jr. became president of Atlantic Wire upon his father's death in 1953. He was born in 1912 at the South Main Street homestead and attended Dartmouth College. After graduation, he worked at a wire mill in Maryland, learning the ropes, then joined the family business, starting as a mill sweeper. He was already involved in managing the company before he became president, particularly during World War II. Soon after becoming president, Atlantic Wire celebrated their 50th anniversary with a public tour of the facility. He was very involved in the community, especially Rotary Club. Mr. Hitchcock was on the board of directors of the Blackstone Memorial Library and among the first trustees of the Foote Family Charitable Trust. The Hitchcock family donated the land to build a new community house in 1963. When the current high school was built in 1958, the family donated $7,000 to build the tennis courts, still in use today. Under his leadership, the company continued to diversify its product line and opened a new plant in Taunton, Massachusetts. Business was still good during the 1960s when the mill had 250 employees and shipped out 25,000 tons of wire a year. The work climate became challenging in the 1970s. Business slowed down with a changing market. Factories moved to the south or overseas. The cost of materials and labor increased. People's habits and use of products changed. It became more difficult and costly to have a business in Connecticut. The Malleable Iron Fittings Company closed in 1970. Factories such as Atlantic Wire and MIF had dumped their chemical waste in the waterways and landfills for many decades. Some of you might remember the Branford River had a reddish-brown color from the ferrous sulfite. Sewers didn't come to Branford until 1960 and could not meet the capacity for factory waste. The state started fining companies, including Atlantic Wire, for pollution, and many smaller factories closed due to the cost. In 1966, Atlantic Wire installed a $170,000 system to neutralize sulfuric acid. the best available system at that time and the first used in this country. It was not perfect, and the sludge at the bottom was brought to the landfill. The 1970s brought more pollution requirements. Mr. Hitchcock stepped down as president in 1976 and became chairman of the board. Other partners purchased part of the company. The Hitchcock family sold their majority interest in 1984. The wire mill continued to be a busy factory for much of the next 25 years, with 3 shifts working 24 hours a day, but the workforce was gradually reduced. There were 2 successive owners with different management styles and business goals. The Atlantic Wire Company closed in 2008. There were 71 employees left. The reasons why a factory closes are many and complex, but it is a common tale throughout Connecticut and New England. Some of the factors have already been discussed: a challenging and declining business climate, customers' use of plastic and other materials, labor, material, and equipment costs. There were state taxes, pollution recovery costs, and increased state and federal regulations. The cost of upgrading aging equipment and buildings were among them. In 2016, a new mixed-use development is planned for the site, and all the old buildings will be torn down. We have just touched the surface of the complexity and diversity of the operation and products made from Atlantic Wire. Branford's wire mill was one of the first companies in the country to use electric overhead hoists, tungsten carbide dies, Salt and Lee Wilson annealing, and other innovations. Atlantic Wire was a pioneer in producing galvanized wire. There were many other departments and jobs at the factory, all of which made the company a success for 100 years. We have discussed the Hitchcock family, their association with Atlantic Wire, and the community. No business can operate for that many years without a management team, such as Elmer Tyler, pictured here, who worked at Atlantic Wire for over 50 years. He was an expert in all aspects of wire. Key, though, to the company's success were the many workers, mostly men and a few women, some of whom worked at the factory for 40 years or more. This was hard physical work, hot and dirty. In the early years, the workers were Yankees and some Scandinavians. They were joined by men from Italy, Poland, other East European countries, and African Americans. These men were skilled at their jobs and hard workers. They were crane operators, tinners, galvanizers, truck operators, foremen, cleaners, tool and die makers, chemists, shippers, inspectors, and many more. Hundreds of men during the company's existence worked as wire drawers. Atlantic Wire was an important employer, taxpayer, and member of the community. As one employer said, with all the machines operating 24 hours a day and the many products being made, it was an exciting place to be.